In a worst case of what the climate will be at the end of the century. Let me tell you what the models are showing for the Caribbean region. It's a pretty daunting picture. Firstly, our temperatures will continue to rise. So what are you looking at? The top two panels are the best case and the worst case, and the bottom two panels are the better case. In the panels, if I can coin the phrase, the oranger it is the hotter it becomes. Can you spot Jamaica in it? It doesn't matter which scenario you take, the Caribbean is going to be hotter at the end of the century. And by how much will we be hotter? We'll be hotter by 1 to 3.5 degrees hotter. And the same pattern of warming is going to happen. So the daytime temperatures are going to warm and the nighttime temperatures are going to get even hotter. Now, if we're troubled already, can you imagine as we go to the end of the century? And the kind of warming we see is going to historically exceed any kind of warming we have had already. But the models also say it's not only that we are going to get hotter, but here is the rainfall. And everywhere that it's brown, it's dry at the end of the century. And if you can spot Jamaica amidst the brown, it's brown no matter what scenario you take. And so the general tendency is that we're going to be drier in the main Caribbean basin by the end of the century. Anywhere between 25 and 30% drier in the mean. What does this suggest? Well, the problem with the drying is that we are sure we are going to be driest in June, July, August, September, and October. Remember that pattern of the seasonality pattern. We are driest when we expect to get rain. And it's not only that the models are telling us that our temperatures are going to continue to increase and that we're going to get drier, but the models are also telling us that we're going to have more intense storms. So the top panel is category 4 and 5 hurricanes now. The bottom panel is category 4 and 5 hurricanes in the future. So not necessarily more hurricanes, but certainly more intense hurricanes. And then if the temperatures will rise and the rainfall is going to get dry and we're going to get more intense storms, we're going to have higher sea levels. And if you can make out the diagram on the left, there are little lines coming in from the coast. And each little line represents how much land is taken with 1 meter, 2 meter, 5 meter, etc. levels of sea level rise. People often can't envision, well, what does 2 meter sea level rise mean? Here's what it means. 1% of Jamaica land area will be lost. The people who live in those 1% will be displaced. 20% of our power plants are going to be lost. 18% of our tourist resorts will be damaged. 60% of our airports, I don't know which 60 that is, will be gone. 2% of our roads that ring the coast are lost. And 100% of our port structure, I don't want to say that with prof in front of professionally, but that's just one study. But you get the concept that this is significant. With that kind of picture of rising temperatures, rainfall that is drying out, more intense storms and higher sea levels, can you see that the impacts are going to be significant? And if the sensitivity was pervasive, and if the vulnerability was pervasive, then the impacts are also going to be pervasive. So we'll have health impacts, dengue. We will have agricultural impacts, food security threatened. We'll have forestry impacts and water resources impacts and coastal areas and wildlife, and you name any area of life. If the sensitivity and the vulnerability is pervasive, then the impacts are also going to be pervasive. Let's just push this. If then we do not have action, so in the face of inaction, there are a couple of things we want to bear in mind. Firstly, in the face of inaction, the impacts to climate change are then only going to grow. And they're going to grow at differential rates. What do I mean? Well, the impacts of sea level rise, the drying that I'm telling you is going to go on to the end of the century. And even something like ocean acidification have a characteristic that they are creeping. So they are really slow impacts over time. So much so that you could almost miss them. But then the impacts of something like an intense hurricane, you can't miss. but you get this growing impact, and the growth will be at different rates. What does this mean? This is a call, therefore, for action, and action which is supported by monitoring. We have to begin monitoring now so that we do not miss the impacts, especially those that have that creeping characteristic. But the first thing that we can tell from all the impact studies is that the impacts of climate change will only grow, though at differential rates. A very similar thing is that when the impacts are going to grow, some thresholds beyond which effective response are possible are going to be attained and exceeded. So we're going to go over some thresholds. What does that mean? One very recent threshold that was in the news quite a lot was the temperature threshold. So if you look at that diagram, the left-hand side is a present, how our present temperatures are changing. And the right-hand side are the various scenarios of how the temperatures are going to change going into the future. Moore et al., who did the study, came up with a term that they called departure, and they said, if I take the warmest year that I have seen to date, and I draw a line from the warmest year I have seen to date going through the end of the century, and I find the first year when the coolest temperatures we will experience thereafter are warmer than the warmest temperatures we have received to date, that's my climate departure date. It turns out that for Jamaica, that date sits somewhere in the mid-2020s. Climate change is not something distant. In fact, they put a date of 2023 when we will have reached temperature departure. Now, when we have reached temperature departure, lots of things will happen because we'll have moved out of the realm within which biodiversity will be able to live. And it's not hard to think that if we can come up with a temperature departure date, then in the socio-economic realm, we can also come up with departure dates. And some of them we might already have passed. It's a strong possibility that, in fact, the current design standards and siting for critical social infrastructure, we may have already passed that departure date. So we get the concept. The impacts are going to grow, and as they grow, some critical thresholds beyond which response is effective might be passed. Let me say one more thing quickly. The impacts not only are going to grow and some thresholds are going to be passed, but the impacts are going to be unequally distributed and disproportionately affect some more than others. If I was thinking sectors, I could immediately say that the water and the agriculture sector are probably going to be disproportionately impacted on the climate change. But we can extend it, because some existing inequities will likely only increase, especially if resources remain scarce to deal with them. So we're going to have disproportionate impacts, and probably those who will feel it most are the urban poor, the subsistence farmers, the physically challenged, the children, the elderly, the small businesses, and of course the natural environment. And then one last thing about these impacts in the case of inaction. They are going to be costly. I'll just tell you the results of one study that estimates that if we just consider hurricane damage, tourism losses, and infrastructure change due to sea level rise, the Caribbean's annual cost of inaction will be US 22 billion annually by 2050, or 46 billion by 2100, or 10% and 22% respectively of the Caribbean economy in 2004. What about for Jamaica? The cost as a percentage of 2004 GDP will be 13.9% in 2025, 28% in 2050, 42% in 2075, and 57% by the end of the century if we do not act. The costs are going to be costly. What is all of this saying? There's clearly a case being made by climate for urgent, informed, targeted action. Before I leave this third point, let me just say, is it that there has not been any action? In fact, I am arguing that there is evidence of recognition for the need for action. So if I go on the regional scale, I look to the fact that in 2005, the Caribbean Community Climate Change Center was formed, or the 5 Cs. And the 5 Cs is a CARICOM mandated entity to put climate change on the map of CARICOM countries. And the 5 Cs have come up with what they call a regional framework for countries to deal with climate. And then they have gone further and come up with an implementation plan for the regional framework. And if I come local, we have both a ministry and a division that has climate change in its name. And the recent CAP study tells us that 80% of the people in Jamaica know the term climate change. So there is not a lack of recognition about climate change. Yet, in my reading, the following are also true. Climate change is seen as important, but not a priority. Climate change is seen as an add-on when we have dealt with everything else, but not integrated from the outset. And climate change is largely responded to when it is convenient to do so, or when the project funds are available, but not something to go out of your way for. Put all of that together, can you see that our state is inertia? Let me put the inertia one last step. If you want to see evidence of inertia, just look at our attitudes to climate change. I'm going to argue that our attitudes to climate change are the following. One, we either have complacency about climate change. So we recognize that the climate is changing, and then we simply just accommodate, make plans to accommodate for the change. So it is getting hotter, we buy a fan and burn it all through the night. But the problem with accommodation is, of course, that it usually leads you to choosing the easiest or the most convenient option, but not necessarily the best option. And if we're not suffering from complacency, then we're suffering from amnesia. So when we are in the midst of the discomfort brought on by the climate extreme, we make plans so that if we ever fall into this trap again, you bet that we will be prepared. But once normality comes back after the extreme has passed, we gradually forget about the inconvenience until the next time the extreme comes around. And if we're not suffering from complacency or amnesia, we're suffering from minimization. What do I mean? So we recognize a threat, but we say, boy, 1 millimeter per year rise of sea level is just really too small to bother about. Or 1 degree rise in temperature is really just too small. And so I don't have to worry about it now, maybe later when it gets bigger. So we minimize the threat. And if it's not complacency, amnesia, or minimization, then it's resignation. So we throw our hands up in the air and say, boy, there's nothing I can do anyway, it's going to happen. And if it is not resignation, then we pander to uncertainty. So we claim, boy, we just don't know enough yet to really begin acting. So better just keep doing what we're doing now. In the meantime, all the signs of inertia. Why? Because all of them recognize that there is a need for action. All of them recognize that the climate is changing. But the action that they engender always falls short. Because complacency makes you not proactive, and so the action does not have the proactive element. And amnesia means that if you're always responding to the current threat, then you haven't prepared for the future threat and how climate is going to change, and the action is not adequate. And minimization means that the action is not urgent because it is too small to deal anything now. And then certainly resignation and uncertainty means that you don't even bother to act at all. And so all of them, though there is recognition, the action then becomes limited or absent. So what is climate demanding then based on my third observation? If based on my first observation of sensitivity, climate was demanding attention, and based on my second observation of vulnerability, climate was demanding consideration, then certainly, based on everything I've shown you, climate is demanding action. And it is for that reason then that you can see variable C in my equation must be inertia. But when I fill it in, it now becomes apparent why climate demands change. Because if that is the equation of our current state, then sensitivity plus vulnerability plus inertia does not equal sustainability. Climate demands change because otherwise the pieces don't fit together, or otherwise said, things just don't add up. Well, this is our current state, sensitivity, vulnerability, and inertia. And it doesn't add up to sustainability. Let me just quickly say, what it really does is that it threatens sustainability. So it acts in reverse. Because it turns out that climate, everything that I've really been saying, I can sum up by saying climate is impacting the region's geophysical, biological, and socio-economic systems.